Season 2. Here we go. The first 8 episodes, we learned the parts inside out, one at a time. Orders of magnitude, scaling, caching, splitting databases, going async. Starting today, no more learning parts. Now we start designing a complete system, for real. First problem, the Twitter timeline. That feed you scroll. The latest tweets from everyone you follow, merged together, handed to you in order. Sounds simple. But behind it is a problem that gets read hundreds of billions of times a day. A wave of people refresh in the same second. How do you get each one their own unique timeline in a fraction of a second? First, do the math. A design problem always starts with the numbers.
100 million active users, 500 million tweets a day. That averages out to 6,000 writes per second. But the timeline reads 250 billion a month, 100,000 per second.
Did you catch the key part? Reads are more than 10 times the writes. Remember this ratio. Every decision later in this episode is set by it. Let's start with the most intuitive approach. The moment you open your timeline, I go pull the latest tweet from each of the 100 people you follow, grab them, merge, sort, hand them to you. This is fan out on read. Pull.
Writing a tweet is cheap. You just append to your own list, 0.4 microseconds. But the read? Every time, you merge 100 followees on the spot.
The write got cheap, but the read got expensive. And reads are the vast majority. You paid a fortune to optimize the cheap operation and left the expensive one sitting on the hot path. You hit a wall. Flip it around. The moment someone posts, I push that tweet straight into every one of their followers' timelines. Pre-computed. This is fan out on write. Push.
The write got expensive. One person posts, it fans out to their 100 followers, 100 writes. But the read becomes grabbing one pre-computed list. O of 1, 8 microseconds.
The read got 9 times faster. Savor that trade. The write costs a little more, but you write once and serve millions of reads of that tweet. Choosing pull or push isn't about the cost of one operation. It's about the read-write ratio. On Twitter, reads crush writes. Push wins. But push has one deadly corner. Celebrities. A big account with 1 million followers posts one tweet.
Under push, that one tweet is 1 million timeline writes, 16 milliseconds. A normal user, 100 writes. A celebrity, 1 million. 10,000 times the work.
One tweet, one write storm. Every time they post, the whole system shudders. The fix isn't picking pull or push. It's to split them by follower count.
Normal authors still push. Celebrities, no fan out.
When a reader loads, take their pre-computed timeline, add the recent tweets from the few celebrities they follow, and merge on the spot. The blow-up, gone. This is how real Twitter does it. Timeline, done. But Twitter has another half. Search. 50,000 tweets. Look up one word.
The dumbest way. Every query reread all 50,000. O of n.
N gets big. You're toast. Change the data structure. Inverted index.
One word maps to a list of post-ids that contain it. That's a posting list, built once. A query becomes a single dictionary lookup, about 110,000 times faster.
The core is one sentence. Turn a scan into a lookup. Pay once to build the index, and every query gets 110,000 times faster. A multi-word query is just intersecting a few posting lists.
This is the core of Lucene and Elasticsearch.
So where does AI touch this? It touches 2 places. First, the order of the timeline.
In reverse chronological order, what sits on top is the newest. GMA, a promoted ad, lunch was okay. Learning to rank. Score by predicted engagement, closeness, and relevance.
It pulls things like your friend launching a startup or a big model release right up to the top. Your For You timeline is ranked, not chronological. Second, the definition of a hit in search.
Keyword search for caffeine wants the exact word. The corpus doesn't have that word. 0 of 5 hit. Vector recall goes by meaning. Coffee, espresso, latte. 3 of 5 come back.
Modern search uses both. The inverted index keeps it exact. Vector recall catches the near synonyms. Hybrid retrieval. Run the 4 questions quick, and the last one is the honest note.
Where it helps. The timeline goes from reverse-chron to ranked, and search goes from keyword to keyword plus vector recall. What it replaces. Reverse-chron gets replaced by a ranking model, and pure keyword gets replaced by hybrid retrieval, inverted index plus vectors. What changes? A ranking stage gets added after the fan-out service, and a vector index gets added next to the search index.
So what can it change? Real talk. AI doesn't change fan-out on read and write, the celebrity problem, the inverted index. These bones, it hasn't touched at all. All it swaps is 2 muscles, ranking and recall. Get the skeleton wrong. The fan-out blow-up goes untreated, and no model, however good, can save it. Before we wrap, a few traps. 1. Think about the read-write ratio first, then choose pull or push. In a read-light, write-heavy case, forcing push is asking for pain. 2. Celebrities have to be handled specially. Without the split, one big account can drag down the whole site. 3. An inverted index isn't done the moment you build it. Delete a tweet, edit a tweet. The index has to update right along with it. 4. Don't jump straight to AI ranking. Get the skeleton. Fan out, caching, indexing. Built right first, then talk ranking. 5. The timeline cache is in memory. The read is kind, expensive. Pre-compute only for active users. Don't keep a copy for dead accounts too. Let me weld it shut in one line. That one timeline you scroll, behind it is the fan-out read versus write trade, the celebrity split, the inverted index for search, plus AI's ranking and recall. And this whole thing is just the parts from the first 8 episodes. Caching, sharding, queues, load balancing, bolted together. That's the truth of a design problem. You don't invent new parts. You assemble what you've learned into a system that can take real scale. Next problem, we design a web crawler. The Bloom filter is about to take the stage. See you.